Hi all, welcome back to my channel. In this video, I'll show you how to create a 2D enemy patrolling AI where the enemy will perform the normal patrol movement until the player comes in the enemy's attacking range. After which, the enemy starts chasing the player while facing towards it and stops chasing once the player reaches a safe distance. With that being said, let's get started. So this is our scene view. Let me just walk you through the game objects that I've included. So the first one is our normal ground. It has a box provided 2D, that's it. Then we have a ceiling. This is just for the main game window. So it looks like this, nothing more. Then we have a player game object. A game object contains one box provided 2D. Over here, it also contains rigid body 2D so that we can move it left, right, or perform any physics related movement. And the gravity scale is 20. The collision detection is continuous, and I have also constrained its rotation in the z-axis. Now inside our player game object, we have one more game object. This one empty game object, and I have simply added the box collided 2D component over here. We zoom in, you can see this is the point. This trigger is true because we only want this ground check game object to trigger the on collision events like on trigger enter 2D or on trigger and exit 2D. So that's why the is trigger is checked. Nothing major. This will be used for checking whether the player game object is on the ground or not. Now let's check the script graph for our player game object. Let's start from here. This particular logic is only to flip our player game object so that if we are moving to the left direction, it looks toward the left direction. So over here we are doing nothing, it's simple. We are simply checking if the x value or the horizontal value is less than 0. That means if we are moving to the left direction, if that is true, then we are simply setting the local scale of our player game object like this, where we are passing -1 in the x component. -1 because to this the player will be looking towards the left direction. If this is false, then we are checking if the horizontal value or get axis row value from this node is greater than 0. That means x is on the positive direction, we are moving towards the right direction. If that is true, then we are simply setting the local scale of our play game object as 1, 1 and 1 so that it looks towards the right direction. This logic is only for the player movement. It's simple. We are simply setting the velocity of our player game object in this way, where for the x component, we are passing the multiplication value between this node. From this node, we will be getting either -1, 0 or 1. And we are multiplying that value with the player speed. So we have this variable created over here with a value of 10, and we are simply passing it in the x component of our vector 2. For y, we are simply fetching the y component of our current player's velocity. For jump, I have used this node on keyboard input, where if space key has been pressed down, then we are checking first if is grounded is true or not. So it stores a boolean value. It could be the false or true. If this is true, only in that case we are setting the current player's velocity in the y direction like this. So for y, we are simply passing the jump force, which is 45. For x, we are simply getting the x component of our current velocity for the player game object. And this logic is only for checking whether the player is grounded or not. How we are checking? So we have created one new variable, ground check, and we have selected a type as ground game object, and we have selected the ground check object that we created inside a player game object. Now what we are checking, if our ground check game object collided with a game object which is having the tag as ground. If this is true, that means if our ground check object collided with the ground game object or any game object which is having a tag as ground, then we are simply setting the is grounded variable's value as true. And then for the second scenario, we are checking if the ground check game object is leaving a collision and the last collided game object was ground. If this is true, then we are simply setting the is grounded variable's value as false. That's it. Now let's go back. Now let's check the enemy game object. For enemy game object, I have simply passed or used one box collided 2D component, nothing major. Over here, this is the component, and I have also created one script machine for it. Before we go over that, I'll just also mention two more game objects that I've created. The first one is point 1. So this is the point in the left direction for our enemy game object. So this will be the last point till our enemy game object will move towards the left direction. Similarly, for point 2, this is the direction and our enemy game object will move the right direction till this point. So this is similar to what we have done in our moving platform video. So you guys can check that out as well if you want. Now let's head back to our enemy script machine. So the type of AI that I have created for this enemy UI AI is kind of a patrolling AI where the enemy in its normal state will keep on patrolling. That means it will go to the point 1 direction or location. Once it has reached the point 1 location, then it will move towards the point 2 location or position. If our player gets near to our enemy game object or to a certain point, let's say around 5 floating values, then our enemy game object should start chasing the player. So this is the whole scenario or logic that I've used in this case. Now, these are the variables, the speed of our enemy game object. This is the patrolling speed. Then I've created a list of transform type of variable which stores both point 1 and point 2 values like this. It stores the transform of those two game objects values. Then we have our next position variable which is of vector 3. This will store the next position our enemy game object should move towards. Then we have our is attacking player, the player game object or reference to our player game object, and then the player chasing speed. We want to keep our player chasing speed of our enemy game object to be different. Now in our start node, we are simply setting the next position variable's value with the position of our first point. So wherever our first point position is, we are simply setting that position the next pos variable's value. So you see this node actually fetches the element mentioned in the or element present in the mentioned index number, because point 1 is the first element, so that's why we have used 0 over here. If we wanted to get the value of point 2, then we would have used 1 over here. Over here, simply setting the value of next position. Now in our on update node, we are setting the enemy's next position, or we are calculating it based on the enemy's current position. So let's go over that. So this is the subgraph that I've created. It's pretty simple. So over here, it starts from here. We are simply checking if our enemy's position is equal to the point 1's position. That means our enemy has reached the point 1 position. If that is true, then we are simply setting the next position's value with whatever value we have for point 2. You see, we are fetching the item in the index 1, which means this one, our point 2. We're fetching that position and simply passing it in the next position. If this is not true, then we are checking if our enemy's position is equal to the point 2's position. That means our enemy game object has reached the point 2 position. If this is true, then we are simply setting the next position value as point 1 position, this one, so that it keeps on doing a patrolling, like going to the left direction, then right, then from right to left. That's it. So this next position value or variable stores to that position or the next position that the enemy game object should move towards. Now after this, I am simply checking if our enemy game object is attacking the player. That means if our player game object is actually near to the attacking radius of our enemy game object. How we are checking it? So again, for this one, I've created one subgraph. I'll open it. So it's pretty simple. It's simply checking the difference or distance between our enemy game object, this one, and the player game object. So over here, this node gets the position, like the vector 3 values of our enemy or current game object, and this one fetches or perform the same thing. It fetches the position of our player game object. This node simply calculates the difference between these two positions and passes a neutral value. Now over here we are simply checking if the difference between these two positions is less than 5. If this is true, then we are simply setting the ace attacking player's value as true. Else we are setting it as false. Now if I go back over here, once this is set, then we are checking if our is attacking player value is true or false. If it is true, that means our player should chase towards the our enemy object should chase towards the player or chase the player. So for that, it's pretty simple. We are simply setting the enemy game object position in this way. Where we have used our move towards node. It takes three values. The first one is the current game object's position. So we are passing the enemy's current position over here. The second value it takes is the target position where it should reach towards to. So in the target, we are passing the position of our player, but there's a trick over here because this is a side scroller, or this example is a side scroller. So that's why we are only getting the X component of our player game object position. For Y and Z, we are simply passing the enemy's Y component and Z component of the position. I hope this is clear. So for X, because we want to move towards our player object, that's why we are fetching the X component of our player game object's position. And for Y and Z, we are simply passing the same values of the enemy game object position. For the third value, we are simply passing the player chasing speed, this particular variable, and we are multiplying it with time dot delta time so that it's frame rate independent. And we are simply passing this value as the position. After this, what we are checking is simply checking if our enemy's X component value, or I would say our player's position's X component value is less than our enemy's X component value. That means our player is on the left side of our enemy game object. Then we are simply flipping our enemy game object like this. We are passing -1, 1 and 1 to our enemy's local scale so that the enemy looks or faces towards the left direction, towards the player. Else, that this means the player is on the right direction. So our enemy game object should also look towards that direction. So that's why we are passing 1, 1 and 1. So this was the subgraph for chasing. Now for patrolling, we are simply passing the next position in the target location, in the target value or input. We are simply setting the enemy's position in this way where we have used the move towards node takes three values. The first one is the current position of our enemy game object. The second one is the target position where it should reach. Over here we are passing the next pause variables value, and for the third input variable we are passing the speed, this one, and we are multiplying it with the time dot delta time node. And again we are checking the same thing. If our next position's x component is less than the x component of our enemy's position, that means the player should move towards the left direction. That's why we are simply changing or setting the local scale of our enemy game object like -1, 1 and 1. Else we are setting it as 1, 1 and 1. That means the enemy should look towards the right direction. So that's it. Okay, so you see our enemy currently moving to right. Once it reaches point 2, it will move towards the point 1 direction. It's also changing its rotation or flipping. Now, if I get close to our enemy game object, it starts following or chasing the player. Once we reach a safe distance, the enemy game object goes to its normal patrolling cycle. Now again it's changing, and because we are in the left direction, the enemy game object also looks towards that direction. So you see, let's bring it over here. Once the difference is greater than 5, it simply goes back to the patrolling state. Now if I'll jump over here, now you see it moves to the right direction. Once the distance is greater than 5, it simply goes back to perform its patrolling motion. If you guys learned something new, then I request you to please like this video and subscribe to my channel so that I can create more videos related to Unity's visual scripting in the future. Thank you for watching, and I'll see you in the next video.